Okay, today we will be doing angles of any magnitude. Firstly, we're going to look at the equation of a circle. And if I have a circle with center 0, 0 and radius r, my equation is x squared plus y squared equals r squared. Center 0, 0, radius r. If I change all those r's to 1, that gives me the equation x squared plus y squared equals 1. I now have a center 0, 0 and a radius 1. This is the circle that I will be using to show you angles of any magnitude. It's called the unit circle. It actually works with any circle, but this is the simplest one that I'll be using. When we measure our angles, we start from this axis here, the x-axis, and we measure in an anti-clockwise direction. Okay, so anti-clockwise. The first quadrant is this section over here. So if I put any triangle in the first quadrant, I'll be measuring between 0 degrees and 90 degrees. The second quadrant goes up to 180. The third one goes up to 270. And finally we go back to 0 or 360. So if I put any triangle in the first quadrant, there's my angle theta. And my radius is 1 because I'm using the unit circle. So from here to here, that's the radius, and that is 1. This x value here, I mean, it varies because you could draw any triangle, but we know that it's always going to be positive. Similarly, this y value, it varies because you could draw a triangle that's thin and long or wider and shorter, but it's always going to be positive. I can then write my trig functions. Sine theta is equal to opposite over hypotenuse, so it's a positive number over 1, which means that sine is always positive. Cosine is equal to adjacent over hypotenuse, so a positive number over 1. So cosine is also always positive. The tangent, opposite over adjacent, so positive over positive, which will always give a positive number. So in the first quadrant, sine is positive, cosine is positive, and the tangent is positive as well. If we do a similar thing in the second quadrant, put our angle in, our radius is 1. This time, these x values are negative, but these y values are still positive. Okay, because y is above the x-axis, whereas on this side, the x values are negative, but over here, the y values are positive. So sine theta in this case is positive over 1, so sine is still positive. Cosine is negative over 1, so cosine is now negative. And the tangent is a positive number over a negative number, so the tangent is also negative. In the third quadrant, if we do a similar thing, put in our radius as 1, the x values are still negative, the y values are now also negative because y is negative down here. Sine theta is negative over 1, which is negative. Cosine is negative over 1, which is also negative. And the tangent is a negative number over a negative number, which cancels to make a positive number. And finally, in the fourth quadrant, if I put my angle in, radius is 1. The x values here are positive. The y values still negative down here. Sine is negative over 1, which is negative. Cosine is a positive number over 1, which is positive. And the tangent is a negative number over a positive number, which is negative. In summary, in the first quadrant, sine, cosine, and tangent were all positive, so they were all positive. In the second quadrant, sine was positive, the other two were negative, so only sine was positive. In the third quadrant, tan was positive, the other two were negative, so only tan was positive. In the fourth quadrant, cosine was positive and the other two were negative, so only cosine is positive. There is a nice acronym to remember that. All stations to central. And you work yourself anti-clockwise. Okay, so now we're going to learn how to write the angles. In the first quadrant, well, that's just theta. It's just normal. It's what you've been doing up until now. In the second quadrant, remembering that we measure from the x-axis anti-clockwise, if I want to go this distance, then I go 180 degrees, and then I can go back theta, and then I will arrive at my destination, so that is 180 minus theta. In the third quadrant, I go 180 degrees, and then I add theta. So this is 180 plus theta, because I travel 180 degrees to get here, and then I add theta to get to my destination. And finally, in the fourth quadrant, if we want to measure from the x-axis, we do 360 minus theta. So I go 360 degrees all the way around, but then I go back theta so that I arrive at my destination. So what does that mean? That means that when we encounter angles in the first quadrant, we just write them normally. When we encounter angles in the second quadrant, we try and write it like this. Sine of 180 minus theta, cosine of 180 minus theta, tangent of 180 minus theta. In the third quadrant, we try and write our angles like this. And in the fourth quadrant, we write our angles like this. Now, if we remember our all stations to central, in the first quadrant they were all positive, so they stay the same. In the second quadrant, only sine was positive. So if we write a sine like this, it is equal to just a normal sine because it's positive. If we write our cosine like this, though, it is equal to the negative cosine because cosine was negative in the second quadrant. And the tangent is also negative in the second quadrant. Similarly, in the third quadrant, sine was negative, cosine was negative, but tangent was positive. And finally, in the fourth quadrant, sine is negative, cosine is positive, and the tangent is negative. So after all that, following page is what you need to know. You need to know that when theta is between 0 and 90, everything stays the same. When it's between 90 and 180, these relationships hold. When it's between 180 and 270, these relationships hold. And when it's between 270 and 360, these relationships hold. So the types of questions you'll get, easy type to begin with. In which quadrant is cosine less than 0? So I do my all stations to central. I have cosine's positive because everything's positive here. Cosine's positive here because of the C. So it must be negative here in quadrants 2 and 3. Second type of question asks to find the exact value of cosine 225. Okay, so one way I can do it is I can use my definition, and so I can change 225 to 180 plus theta. So in this case, my theta is 45 degrees. Now I know that according to my definition, cosine of 180 plus theta is equal to minus cosine of theta. So theta is 45, so minus cosine of 45. And my exact value triangle gives me 1 on root 2 for cosine 45. So that's just minus 1 on root 2. You can do it algebraically, that's fine. If you need to do it more visually to begin with, that's also fine. So you draw a quick sketch. 225 degrees is somewhere here. So I draw a triangle. I know that this much is 180, so I need to go an extra 45. I'm also in the third quadrant, so I've put my T there in case I get tan, because tan's positive. I work out my triangle like normal, so I've got 45 degrees. I'm looking for cos, so I find cos 45. I put my minus in front of it because I know that cosine is negative in the third quadrant. If it was tan, it would be a plus, but it's cos, so it's a minus. And cos 45 is just 1 on root 2, and the minus stays there. And I get the same answer either way. If we had these questions previously and no triangle drawn, we would draw a triangle and solve it. A very similar thing happens in this instance, but you're given a qualifier where sine theta is less than 0. So sine must be negative. So sine is negative in quadrants 3 and 4, but tan is positive. Tan is positive in quadrants 1 and 3. You must satisfy both criteria. So tan needs to be positive, sine needs to be negative, so it's quadrant 3. So I draw my triangle, put in my theta, opposite is 5, adjacent is 12, so opposite is 5, adjacent is 12. I use Pythagoras' theorem to figure out my hypotenuse, which is 13, and then I can go about finding sec theta. So sec theta is 1 on cos. Now cos is 12 on 13, adjacent on hypotenuse, but it's negative because it's in the third quadrant. So I put a minus 12 on 13 there. And it's a fraction within a fraction, so I just flip the bottom upside down, and I'm done. Okay, just a little bit of advice on angles bigger than 360. Because the circle has 360 degrees, every time you add 360, you'll get back to exactly the same spot. So if an angle is negative, you can keep on adding 360 or multiples of 360 to make it between 0 and 360 degrees, and then you can solve it like we normally do. If the angle you're given is above 360, so if the question says find cos of 500, then you take away lots of 360 until theta is between 0 and 360. Okay, that's it.